All right, so we're going to start off with one that looks like this, where you have two separate roots, but no other terms. All right, there's no like extra x or extra 2, nothing like that. It's just a square equals a square root. All right, so easiest thing to do is just start by squaring both sides, because you already have step 1 completed. You know, you've already got one of the roots isolated. That's fine. All right, when you square both sides, you're going to end up with this radicand on both sides. So it gets rid of the radical on both. So now you're down to just solving the resulting equation. That's linear. So figure out whatever side you want variables, whichever side you want constants. Like, I'm going to move all my variables to the left and constants to the right. So you get you get x equals 20. So I'm pretty sure that it's going to work, but you just still want to double check it. All right, if you plug 20 in here, you're going to get 40 minus 15. Square root of 25 is 5. 20 plus 5. So it checks out. So if you come up against some of these radicals where you either might have both on the same side or where they're already separated, you just want one on each side, and then you can go through the squaring process. Whatever happens with these radicands, like, you're just going to have to figure out how to solve that. Now the ones that are harder are going to look like this. These are the gnarlier ones. All right, so not only do you have two square roots, but you also have another term, which is your constant 3. You need to isolate one of these radicals. It doesn't matter which one. It doesn't matter which one you leave on the left-hand side. You just have to choose one and keep it there. So let's say I just leave the x plus 2 under that square root, and I move over the other term, which means I need to subtract it from both sides. Make sure that what you have underneath the radical is still the same signs that you started with. All right, sometimes it's really easy to write a plus instead of a minus. So this is considered completing step 1, where you have isolated one of the radical terms. Now you're going to square both sides. Now the issue on the left-hand side isn't that big of a deal, right? The square is going to cancel out the square root. That's fine. But on the right-hand side, you need to use that binomial square rule that we did the other day. Right? So you're going to need to square the first, minus 2 times the product, and square the last. And so for this example, I'm going to actually write that out so you can see what it looks like. So I really want to square the first term. It's minus 2 times the product of each individual term of the binomial. And then when you square the last, it looks like this. So that's that a squared minus 2ab plus b squared. That's what it looks like. If you can do that mentally, great. But a lot of us can't do that in our head. So what's going to happen is that middle term is still going to have a radical attached to it. Right? You only got rid of the radical from the last term squared. So now what you've got is on the step 3 that we did a couple of days ago, it said to solve the resulting equation, or you got to repeat steps 1 and 2. You're going to have to repeat steps 1 and 2 because you still have a radical, which means that you have to isolate the term that still has the radical. And since the negative 6 is connected to it with multiplication, you're going to have to keep it together. Right? So you've got to move over this 9, this x, and this 1 to the left-hand side. You gotta get rid of all of those. Right? So if I keep this x where it's at, and I subtract off this x, they actually cancel each other out. Let's see. When I do this one, I get 9 minus 1, which is 8. All right. And so then what's that going to give me? Is it 6? It's going to be negative 6, right? So negative 6 on the left. And then on the right, I get negative 6, and then I get this square right here. Now you've got two different things you can do. All right, before when we've done this, we've just squared both sides. All right, and the reason why is because usually this number right here, when I divide, it doesn't divide evenly. This is kind of one of the special cases where instead of just squaring both sides, I'm first going to be able to divide by negative 6. And it's only because the right hand and or that left hand number is a multiple of the right, and I don't have variables. So that doesn't happen very often, but sometimes you can actually divide to isolate the radical. And now when you square both sides, you're going to get 1 equals x minus 1. I'm kind of running out of space, so x equals 2. Again, I'm pretty sure that works, but I want to double check. All right. So square root of 4 is 2, square root of 1 is 1, and 2 plus 1 is 3. So it checks out. If you went and you just squared both sides at that step, you just have more work to do. So if you only have constants on the left and you still have a number out here and it divides evenly, then go ahead and isolate the radical by doing division. If not, you're going to have to just go through the old school process. And so this is pretty much the general idea of what we're going to do for two radicals. All right. And the main issue is this rule right here, this expansion. If you have to write out what the rule looks like, then you're going to need to do that. If not, it's fine. Yeah.
I don't know how you got the 2 and the 3.
Right here?
Yes.
That's your rule. So your binomial square rule is that when you have a minus b quantity squared, it's square the first minus 2 times the product, right? And then square the last. And so when I'm in here, the middle term is minus 2. That's from the rule. The first part is 3, and the second part is the root. So you're just multiplying these two together in addition to the negative 2 to get the middle term. Because it's matching this piece right here. Right. So minus 2, A, and B. Other questions, things you guys want to know? Yeah. Which negative? This right here? I'm expanding it out to be this whole thing because it's 3 minus that square root and that whole quantity is squared. So you're having to use this rule to get this step right here. Because I have to square the first term, which gives me the square. All right, that's the first term. Minus 2 times the product, and then when I square the last, that's the b squared. So you're breaking it apart. It's just that you have a radical still in there when you're done. All right? But you're applying this rule. We're going to do it again so you can see how it's going to work a second time. So let's do it again. We'll go through all those steps all over again. And then I'm going to show you a video of another example so you can see a third. And I think by the time you get to the third one, it'll really start solidifying. All right, so now you've got two roots still. Same general format. Again, it doesn't matter which root you decide to isolate. If I want to, I can isolate the second one and move over the first. So it really doesn't matter. You will get the same answer either way. Your process might look different than somebody else's, but the final answer will still be the same. Right, so you need to move over one of those radicals. Once you move that radical over, now you're going to have to square both sides. So on the left side, when you square the square root, you're left with just the radicand. On the right-hand side, you need to perform that same rule. All right, so the first term of the binomial gets squared. And then because this is a minus sign, it's a minus 2 times, again, the first one and then the second one. All right. So this -2 is part of the rule. The other two is because you have your a and your b have to be multiplied together. And then the last part of the rule is taking the last term in the binomial and squaring it. So on the last example, it was -2 times 3 times something, right? And that's because the 3 was the first part of the binomial. So now I'm going to expand out a little bit, or simplify this down. All right. And that last term, again, when I take the square of the square root, just gives me the radicand. So that middle term, again, has the radical in it. So that's the one that I'm going to isolate on the right-hand side. So I have 3x over here now, and I want to subtract off the 5x, so I'm going to get a -2x. Of the number portions, I've got 4 and 6, so I have 10 on this side. And when I take 4 and subtract off 10, I get a -6. And then that middle term is now isolated. So I'm just moving over all of the pieces that are not attached to that middle term. All right, so now you got to square both sides again. Now the left-hand side is a little bit more complicated because when you're doing that binomial square, you've got a bunch of negatives floating around. And so what I'm going to do is I'm actually going to expand out the rule again, just like I have been over here. So it's your a has to be squared. Right. And then it's -2 times the product. And then it's the last one squared. And on the right-hand side, if I square -4, I get a +16. So because it's not just the 4 being squared, but the negative is attached to it. And then squaring that radical gives you 5x plus 6. Now if you have to go off to the side, you could do this right here with an area box to get the same answer. But when you do this, you have to remember that it's -2x times -2x. So it's really a +4 with the x squared. And then in the middle, you get 2 times 2 times 6, which is a +24x plus 36. And then you have to distribute. So 16 times 5 is 80. And 16 times 6 is 96. So if you have to use your calculator to actually do the multiplication, there's nothing wrong with that. But the problem is I need to move both of these terms now to that side. So your 4x squared is fine, but now I need 24 minus 80, which is a -56. And I need 36 minus 96, which is a -60. So the issue so far is being able to accurately perform the two types of rules. Being able to deal with a binomial square rule, as well as that, a times b squared rule. So there you've got the two rules that we've been working with over and over. If you don't do those accurately, then you're not going to be able to get down to this step where now you can try to factor and solve. If you try to do 4 times 60 and say, what are two numbers you can multiply to get -240, they have to be 56, you're going to lose your mind. So take the 4 and see if you can divide 56 and 60 by 4. So I'm going to try to factor this out. And if I take 56 and divide that by 4, I get a -14x. and 60 divided by 4 is a negative 15. So you always want to go back to what we did with factoring to remove the GCF to make your factoring easier if possible. Because now I'm only worried about the product to give me negative 15 and add up to be negative 14. Way easier than negative 240 and negative 56. So when you factor this in, you're going to get negative 15 and positive 1. The 4 is not one of my solutions. All right, 4 is never going to be equal to 0. So I only have two options. All right. Either x is going to be 15, or it's going to be negative 1, or it's going to be both. I don't really know yet. You have to check them both. All right. Do not assume that the positive one is always what works and the negative isn't. All right. So now you got to go back up to the top. I'm going to check this one. So if I plug negative 1 into the top, all right, I'm going to get 5 times negative 1 plus 6. All right. So you're kind of having to check all of this and see is that true or not. And it works, all right, because this is going to give me the square root of 1 plus the square root of 1, which is 2. That's true. So I know that the negative value actually works. All right, I want to look at what happens with 15, though. I already know that's not going to work. This is going to be a massive square root plus a massive square root. That's not anywhere close to being 2. All right? So this one's not going to work. I mean, I'm not even going to bother trying to figure out what that is. That's your only answer. So you definitely have to double check your values. Right? This is probably one of the most complicated of the problems, but if you get stuck on the algebra, it's going to be rough.